Welcome back to the deep dive. This is our fourth session digging into Solera's Nature Positive Production. And today, we're exploring something really powerful. It's this essential marriage, you could say, the synergy between ancient tradition and, well, cutting-edge technology in modern cattle production. Just to quickly bring everyone up to speed, in our last few deep dives, we looked at how Solera's Tule and Mashona cattle bring these frankly amazing economic benefits. We saw their fertility, their meat quality, incredible resilience. These aren't just nice treats. They're proven pathways to really surprising profitability. We talked about boosting profits by maybe 25, even up to 100%, which is just huge. Then last time, we took that big journey back, didn't we? 700 years tracing the history of these African genetics, from the, sophisticated breeding by the Shona people through colonial research, right up to the modern science that brought these genetics to Australia. So after looking at that economic power and the sheer depth of that history, it kind of begs the question, right? How do we actually take this incredible legacy and make it work for today's world? Which is pretty complex.
That's exactly the point. See, modern cattle production, it's facing this really multifaceted challenge now. It's just not enough anymore to focus only on fertility, which was maybe the main goal back in the 1950s. Today, you've got this whole web of demands. Yes, the market profitability, that's fundamental always, but also these increasingly critical interests in, enhancing biodiversity, getting positive ecological outcomes, reducing our environmental footprint. It's a very different picture. And while those traditional methods, the ones developed over centuries, they hold this, profound wisdom, they really do need modern validation and precise application. That's key to really meet these diverse and sometimes competing goals effectively. This kind of integrated approach lets us look at and improve everything together: fertility, meat quality, growth, feed efficiency, while also using advanced tech, things like IVFs, or even tools like carcass cameras, walkover weighing systems. The aim isn't just an animal, it's an optimized animal, one that thrives, makes good money, and actually helps the environment it lives in.
I see. Okay, so it's about knitting together that ancient know-how with the latest science to tackle these newer, more complex demands. How does the Solera framework actually start to, build that bridge between these two worlds? They seem so different on the surface.
It really starts with a fundamental shift in thinking, recognizing the deep research-backed value of that traditional knowledge. Study after study shows that combining indigenous knowledge with modern science, it's actually crucial for improving genetics. Those traditional selection criteria, they serve as a really vital baseline for designing modern genetic programs. It's about building on centuries of real-world observation, not just starting over in a lab.
Okay, so we're talking about what people sometimes call indigenous technical knowledge, or ITK. And my understanding is this isn't always written down like a scientific paper, right? It's often passed down generation to generation through practice. But what you're saying is studies are proving these traditional practices aren't just, old wives' tales. They actually have real scientific merit. Precisely. And what's really fascinating is how these generations of traditional selection managed to preserve key adaptive traits long before modern science even understood the genes behind them. I mean, think about it. Drought tolerance, incredible heat tolerance, letting them graze when it's over 40 Celsius outside.
Wow.
Natural resistance to ticks, tick-borne diseases, even resistance to things like trypanosomosis, that's tsetse fly disease. These traits were identified, selected for, preserved through careful observation and breeding choices over hundreds of years. Not through microscopes initially, but their genetic effectiveness. Totally verifiable today.
This is where it gets really compelling for me. How does the technology actually enhance that? How does it speed up what traditional breeders were doing? How does that ancient wisdom get this, modern turbocharge? It creates this truly integrated approach. Let's maybe walk through a few examples. Take bloodline memory meeting genetic tracking. Traditionally, indigenous practices, like with the Zulu Kingdom, involve this incredibly detailed knowledge of mating systems, performance, passed down orally, mostly. Almost like their own kind of performance testing and genetic record keeping.
Right, a living database.
Exactly. Now, today, genomic selection gives us far greater accuracy in predicting genetic merit, even in really young animals. That means shorter generation times, higher selection intensity. We can make genetic progress much, much faster. And whole genome sequencing. It gives us this incredibly detailed map of the animal's entire genetic code. Helps us pinpoint specific variants influencing those traits we care about, the economic ones. Plus, with international evaluations, we pool data globally. Breeders get access to way more elite animals, boosting the accuracy of estimated breeding values, the EBVs. These are basically data-driven predictions of potential. It's the old concept, but supercharged with data.
That is a huge leap in precision, isn't it? And these breeds, they're famous for adapting to their local environment. How does that deep-seated ability connect with modern climate data?
Well, indigenous cattle evolved over thousands of years in incredibly different environments, often harsh ones. This gave them genetic variations that are just invaluable now, especially with our changing climate. Their natural heat tolerance, like we mentioned, let them graze when other breeds couldn't. Their efficient water use, surviving on very little intake. It's survival baked into their DNA. So now, genome-wide sequencing gives us powerful tools to identify the specific genes related to things like body temperature regulation, adaptation to extreme climates, even in crossbred animals. Research now really backs up optimizing breeds specifically for local conditions and, importantly, for future climate challenges. We can see why they're adapted and breed for it more effectively.
And pasture management. I know traditional pastoralists had this almost intuitive feel for the land. How does that mesh with, say, satellite tech?
Traditionally, you're right, pastoralists showed this really deep understanding of feeding, drought management, using resources sustainably, all based on environmental knowledge passed down. You can even see it archaeologically, like at Great Zimbabwe. Sophisticated water management systems, creating microclimates for better growth. They literally shaped their environment for the cattle.
Amazing.
So the modern enhancement, tools like satellite remote sensing, there's one called a rangeland analysis platform, for example, let us consistently monitor things like pasture biomass, what plants are actually growing there, grazing patterns, all very frequently. This data doesn't just validate those traditional observations, it helps us refine management. You can see from space the impact of grazing patterns that people used to figure out just by looking at the ground. It becomes this really powerful feedback loop between observation and data.
It's like having that 700-year-old wisdom, but amplified by, supercomputing power right alongside it. What about the actual breeding decisions, speeding up genetic progress?
Historically, indigenous communities used their knowledge to boost milk, improve fertility, manage breeding overall. It was crucial for keeping heritage breeds going and productive. That was their decision framework.
Okay.
The technology bridge now involves combining genomic selection with assisted reproductive technologies, RT like IVF, and potentially even gene editing down the line. When you integrate these into structured breeding programs with really clear goals, you can maximize genetic progress incredibly quickly. RT especially lets you get many more offspring from your absolute best genetically elite animals, propagating those superior genetics way faster and with more control. And this also links into developing things like, say, microbiome inoculants or probiotics to improve gut health and feed efficiency, which ties into the next point, too.
Right. Makes sense. And obviously, health and disease management would be another huge area where this blend works.
Oh, absolutely. Farmers traditionally had this great wealth of knowledge about diseases, often using local plants and methods, ethno-veterinary practices that actually have documented effectiveness. Think about the Sangha advantage, their natural resistance to certain diseases like tick-borne ones and just generally stronger immune systems.
Yeah.
And science is now validating a lot of this, showing that ethno-veterinary medicine provides real, crucial care, especially where modern vet services might be scarce or expensive. It's not just folklore, it works. We're also seeing new tech applications here, like those walkover weighing systems. They let producers monitor individual animal health and growth without the stress of handling them, giving early warnings of any potential problems.
That's clever. And finally, what about feed efficiency and grazing behavior?
Well, traditional knowledge definitely includes understanding good feeding practices. Pastoralists were good at spotting the animals that did better on whatever feed was available. Sangha cattle, for instance, were known for efficiently turning sparse savanna grass into protein, a critical skill in their home environments. Modern measurement, like satellite imagery combined with machine learning, can now quantify pasture biomass, the specific plants growing, and grazing patterns in amazing detail. This gives us precise data that validates those traditional observations about efficiency and behavior. It allows for even more optimized, targeted grazing strategies that help both the animals and the land.
Okay, so we've dived into all these specific areas where tradition meets tech. What does this all mean for you, the listener? Whether you're a producer looking for better results or maybe just curious about truly sustainable practices, how does Solera actually put all this together in a practical, real-world system?
Solera's approach is really structured as a practical, research-supported implementation framework. It's designed to seamlessly blend these two worlds. It kicks off with Phase 1, knowledge documentation and validation. This is about systematically recording those traditional practices and then, crucially, scientifically validating them. So, for instance, using traditional mating systems as a starting point for designing modern genetic programs, or checking that traditional knowledge about environmental adaptation against actual climate data.
Got it. Document and verify.
Then comes phase 2, technology integration. This is where we bring in the modern tools to enhance the traditional knowledge. But, and this is important, without replacing the intuitive skills that farmers have built up over years. Think about using genomic testing to confirm what a breeder sees visually when selecting animals, or using satellite monitoring to back up traditional indicators of good grazing areas, integrating real-time weather data with that inherent knowledge about seasonal breeding timing. It's about empowering that intuition with data. Adding things like carcass cameras here gives immediate feedback on meat quality, something traditionalists assess more gradually, by handling and experience.
Okay, so enhance, don't replace.
Exactly. And finally, phase 3 is adaptive management. This creates ongoing feedback loops. Connecting traditional observations with technological measurements allows for continuous refinement and improvement. It's designed as a living system, always learning, always adapting to meet current needs and challenges.
That framework really makes sense for dealing with today's complexities, doesn't it? And the payoff, the benefits of this integrated approach economically, environmentally, they seem really significant.
Oh, they are. This integrated approach leads to real productivity gains. Like we talked about, faster genetic improvement through things like RT can truly transform beef and dairy operations. And from a sustainability view, these indigenous breeds bring invaluable cultural ecosystem services, genetic diversity. It aligns perfectly with modern sustainability goals. We're talking reduced greenhouse gases through better feed efficiency, enhanced biodiversity from adapted grazing, improved soil health, better water conservation, and crucially, conserving these indigenous breeds isn't just charity, it can be properly economically viable.
Right, it pays for itself.
It absolutely can. And all of this translates into solid economic benefits. Things like premium market access for beef produced this way, lower input costs because the animals are naturally adapted, and significantly better profitability overall.
Right.
It really reinforces that potential 25 to 100% profit jump we mentioned earlier. It's genuinely a win for the producer, a win for the animals, and a win for the planet.
It's kind of amazing when you think about it. The circle is complete. Solera seems to be this living bridge connecting that ancient wisdom perfected in African kraals, the traditional livestock enclosures, right?
That's right.
Connecting that with the precision of modern genetic science.
Absolutely. You could say the Solera system is really the culmination of, 7 centuries of genetic evolution and scientific progress. It's about being stewards of this incredible genetic heritage that crosses continents, creating animals that embody those ancient Shona protocols, the Zulu pastoral excellence, the validation from colonial research, right through to modern genetic optimization and today's sustainability demands. It's a lineage that tells a really powerful story of adaptation, resilience, and continuous improvement.
So the critical message here for you listening in seems to be this. Embracing both tradition and technology isn't just some nice idea. It's actually a scientifically validated path. A path to more effective, more replicable, definitely more profitable, and profoundly more ecologically sound cattle production. It really does feel like the future of sustainable livestock.
And maybe a final thought to leave you with. In a world that's increasingly driven by data, by digital solutions, just consider how much valuable knowledge might still be locked up in those tried and true practices, the ones passed down through generations. How can we maybe unlock more of this tacit wisdom in other fields too, blending it with cutting-edge science to find truly holistic, truly resilient solutions for all the complex challenges we face today?
That is a powerful thought to mull over long after this deep dive ends. We definitely encourage you to keep digging into these fascinating intersections of history, science, and real-world application. Thanks so much for joining us on the deep dive.